Here's a nice question where we're asked to solve for t. So the instructions at the top here say solve. First off, I see it's a quadratic, so immediately I'm going to write it in the normal quadratic format, so bringing the 7 over to the left side. Then I'm going to see if I can factor it. So I go things that multiply to -7, add to -5. None of them work. So I guess I'd have two options. I could complete the square, which sometimes is a little tricky, especially in this case when you have a fraction, or you could use a quadratic formula. I'll show you how to use complete the square on this one, and then the next question I'll show you how to do a quadratic formula. So to complete the square, since I can't factor this, I'll move the 7 back. So what you want to do is get everything on the left-hand side, just the t's, numbers on the other side. Then you divide this term by 2, so take -5 divided by 2 and then square it. So I'll get t squared minus 5t plus whatever this comes out to, 25 over 4, is equal to 7. Now I added 25 over 4 here, so I got to add 25 over 4 on that side. Now on this side here, it'll come out to a fraction now. So when I factor this, it'll be t minus 5 halves, all squared. Notice that this 5 halves is the same thing as I get right here. When I divide that first one by 2 and then square it, instead of squaring it, you divide by 2, that's the number that comes down here. Okay, equals whatever that is. That's 6 1/4, right? Plus 7 would be 13 1/4. I think that's about right. 13 1/4. Okay, so now I have on this side I have something squared is equal to a number. So what I want to do is get rid of that square there. So I'm going to take the left side, and I'm going to take the right side. Let's maybe make that a mixed fraction. 4 times that's 52 plus 1 would be 53 over 4. So I'm going to take the left side and the right side and take the square root. So square root that side. So on the left side I'll just be left with t minus 5 halves. On the right side I'll have the square root of 53 over 4. I can take the square root of 4, so I'm just going to leave square root of 53 on the top, and then on the bottom, instead of the square root of 4, it's just going to be 2. So now I want to solve for t, so I'm going to add 5 halves to both sides. So I'll write over here, I already have 53 over 2, and I'm going to add 5 over 2. If you add those, since they have common denominators, really I could write it as the square root of 53 plus 5 all over 2. And so if they're wanting an exact value for t, this would be my exact value. If they wanted an approximation, then I could figure out what the square root of 53 is, add 5 divided by 2. Now one thing that I forgot on here, and hopefully you've noticed it, but I often forget it, but it's something you can't forget, because the solution to any quadratic always has two answers. So when you square root this side to get rid of the square, it automatically puts a plus and a minus on the other side. And so I have to carry that plus and minus down with me everywhere. So in this last thing, I take positive root 53 plus 5 over 2, and then negative root 53 plus 5 over 2. Just as a ballpark, root of 49 is 7, square root of 49 is, or square root of 49 is 7. So this is just a little bit more, so it'll be about 7 point something. So 7 plus 5 is 12 divided by 2, it's just over 6. So it's going to be 6 point something. And the other one will be negative 7. So negative 7 plus 5, that's close to 2. It'll be just over 2 divided by 2. It'll be close to negative 1. Negative 1 point something. Okay, so those would be my two solutions to that initial question. Here's another one. And initially it doesn't look like a quadratic, but it has fractions. So every time there's fractions, I need to, and I'm solving, I want to use that I hate fractions rule to solve. So I'll take the x, I'll take the 1 over x, and I'll take the 13 over 6, and I'll take each one of those and multiply them by a lowest common denominator, which in this case I've got a 1 here, an x, and a 6, so the lowest common denominator will be 6x. So I'll times this by 6x, and this by 6x, and this by 6x. First one will come out to 6x squared. The next one, the x's are a factor of 1, so they are eliminated. So it'll be plus 6 equals, the next one, the 6's are cancel, and so I'll be left with 13x. Again, it's in a quadratic format, and so I'm going to bring everything over here to the left side, put them in the proper order, and then see if I can factor it. 6 times 6 is 36, so things that multiply to 36 and add to 13. 12 and 3, no. 18 and 2, no. 6 and 6, no. There aren't any. So if I can't factor it, I guess I could do the quadratic or complete the square, but probably it makes sense now to bring in the quadratic formula. Don't try and spend crazy amounts of time trying to complete the square or trying to factor something. If you can't factor it fairly quickly, bring in the formula. That's what it's there for. So my formula says x equals minus something plus or minus the square root of something squared minus 4 times something all over, and notice that line goes under all of that stuff, 2 times something. Up here my somethings are, in front of the x squared is an a, and then this is a b, and this is a c. So I'll plug those numbers in. B is negative 13, b here again is another negative 13, a is a 6, and c is a 6. And then down there a is a 6. Okay, so I'll take a negative 13, that'd be positive 13, plus or minus the square root of. Minus 13 squared is 169. Notice it's positive. Careful there. 6 times 6 is 36, and 36 times 4, 24, 144. So this would be minus 144 all over 2 times 6, or 12. Simplifying a little bit more, 169 minus 144, hey, that comes out to a nice number. Isn't that 25? So it'd be 13 plus or minus the square root of 25 all over 12, or 13 plus and minus 5 over 12. So there's my two answers. I can take and go 13 plus 5 divided by 12, and my other answer is 13 minus 5 all over 12. In the first case I get 18 twelfths, which is the same thing as 3 over 2. And in this case 13 minus 5 would be 8, so it would be 8 over 12, and 8 over 12 would be 2/3. So my two answers to solve that question way up here, this one, whoops, a little higher, would be 2/3 and 3/2. Okay, hopefully that helps you in solving those two questions.